Hello there, welcome to another tutorial video of mine. So in this video you are going to learn how we are going to solve quadratic inequality using a sign chart. So come on, let us learn mathematics my way. Okay, learning objective for this tutorial video, we are going to solve quadratic inequalities. So based on my experience, this is one of the least learned competencies during the first quarter. So in this tutorial video, I'm going to teach you how you are going to solve quadratic inequality the simpler way. So let us first recall what is a quadratic inequality. It is an equality that contains a polynomial of degree 2 and can be written in any of the following forms. Ax squared plus bx plus c is greater than or equal to 0. We also have ax squared plus bx plus c is greater than or equal to 0. So that's the difference between the two inequality lies on this sign. So this one is purely greater than. So this is absolute inequality, and then we have greater than or equal to. So on the first inequality, it means that the value on the left side should be greater than 0. So example 0.1, but on the second inequality, we have greater than or equal to 0 is part of the solution set. So that's the difference. So we can also have ax squared plus bx plus c is less than 0, and ax squared plus bx plus c is less than or equal to 0. So the same meaning with the previous inequalities I explained earlier. So this is the generic procedure for solving quadratic inequalities. First, we are going to write the inequality in standard form of a quadratic equation. So in this step, we are going to write the inequality in standard form of a quadratic equation. So from inequality, we are going to transform that into a quadratic equation in standard form. Number 2, we have find the critical values. So I'll show to you what we mean by critical values later. Number 3, construct a sign diagram or a sign chart. Some books use diagram, some books also use chart. So it's a sign diagram or a sign chart. For number 4, identify and record the solution set for the inequality. So this is the final step wherein you are going to analyze which of the following intervals are the solution. Okay, let us have the first example. X squared minus 4x is less than or equal to 5. So before you are going to start, you take note of the inequality being used. We have less than or equal to 5. So again, the first step is to transform this one into standard form of a quadratic equation. So from the inequality less than or equal to, we are going to make it an equation. And then the 5 on the right side, we are going to transpose that to the other side to have a standard form. So the outcome will be x squared minus 4x minus 5 is equal to 0. So from positive 5 to negative 5, because it is being transposed. After that, the purpose or the reason why we transform this into a quadratic equation is to find the critical values. If you can still remember, during the discussion on quadratic equation, you are going to find the roots by any of the 4 methods, usually the factoring and using the quadratic formula. So now, if you can use factoring, you use factoring because that's the fastest way and the easiest way. And then if it is not factorable, then that's the time you are going to use quadratic formula. So in this case, we are going to use factoring. I hope you still remember how you are going to factor polynomials. So we start with these two parentheses equal to 0. And then first thing you are going to do is to identify what are the factors of x squared. And basically, that is just x times x. That's why we have 2x. And then after that, after the first term, you proceed with the last term, which is negative 5. And then you ask yourselves, what are the factors of negative 5? And then considering the middle term, which is negative 4. So what are the factors of negative 5 such that if we are going to combine, it will result to negative 4. So basically, factors of negative 5, we can have positive 5 and negative 1. That's one of the possible pair of factors. And then another pair is negative 5 and positive 1. So these are the whole number, the factors that are whole numbers. Next is you combine which of these pairs will give you a sum of negative 4. And basically, when we combine negative 5 and positive 1, that will give us negative 4. That's why the factors that we are going to use is negative 5 and positive 1. So we will have x minus 5 because it's negative 5, and then x plus 1 on the other parentheses. So again, we get negative 5 and positive 1 because negative 5 times 1 is negative 5. Negative 5 plus 1 is negative 4. That's why it's very important to master factoring. And besides, that is your lesson during your grade 8. So it should be mastered as of this moment. Next, after that, we are going to apply ZPP, or the zero product property, which means if two factors are equal to 0, if the product of two factors is 0, then either one of them is 0 or both of them is equal to 0. That's why we can generalize that x minus 5 is equal to 0 or x plus 1 is equal to 0. And then finding the value of x, we can have x is equal to positive 5. And then on the other factor, we can have x is equal to negative 1. Again, I think this is basic as long as you are learning from your previous lessons. So this one, x equals 5 and x equals negative 1, these are what we call the critical values. These are not yet the answers. These are the critical values. So what we are going to do with these critical values, they are going to serve as the boundary for our intervals since we are dealing with inequality. So on the next slide, this is the time we are going to construct a sign diagram or a sign chart. But before that, let us start with a number line. So again, the critical values that we have earlier, the positive 5 and the negative 1, that will be our boundary. So since we have 5 and negative 1, we are going to have two boundaries. And then notice that I'm using a bold line, not a dashed line, because the inequality that we have earlier is less than or equal to. As long as you have that or equal to, you use a bold line, meaning in our interval, 5 is included. Okay? And then another critical value that we have is negative 1. So again, I'm using the bold line because the inequality that we have earlier is less than or equal to. As long as you have that or equal to, you use a bold line, not a dashed line. Now, if you observe this number line, this is consists of real numbers. So this is a real number line. it is being divided into 3 intervals, 1, 2, and 3. These are the 3 intervals. So what we are going to do, we are going to name the intervals so that at least we have the idea what are the possible numbers that are belonging to that interval. So let us start with the rightmost. We have x is greater than or equal to 5, meaning from this boundary towards right or going to the right, x could be greater than or equal to 5, meaning 5 is included, and then x should be greater than, meaning you can have 5.1, 5.6, 6, 7, until positive infinity, meaning this line is extending infinitely towards the right. So for this interval, it has a lot of values as long as it is greater than or equal to 5. So that is the first interval. Second interval, let us have the leftmost interval. So it doesn't matter the order of your interval. The second interval I'm going to present is x is less than or equal to negative 1, meaning if we are going to interpret that 1, x could be equal to negative 1 because we have this or equal to, or it should be less than negative 1. For example, negative 2, negative 3, negative 4 until negative infinity. So that is the second interval. And lastly, the interval between the boundaries, you look at my notation. X or negative 1 is less than or equal to x because x, if you are going to look at this part, x is greater than or equal to negative 1 because x is located on this interval, meaning x should be greater than or equal to negative 1. That's why on our notation, we have negative 1 is less than or equal to x. So the most lowest possible values of x is negative 1. And then on the right side, it should be that the highest value of x on this interval is 5. So one perfect example in this interval is 0. Why? Because 0 is less than or equal to negative 1 and 0 is less than 5. So after having the intervals, we are going to create a sign chart. So since we have 3 intervals, it means we also have 3 columns for the intervals. And then we are going to write down the intervals on the columns. So we have x is greater than or equal to 5. And then next, we have the second interval. Negative 1 is less than or equal to x. And x is less than or equal to 5. And then lastly, x is less than or equal to negative 1. And then what we are going to write on this part are the factors. So if you can still read the factors that we have earlier before we applied the ZPP, it's x minus 5 and x plus 1. So x minus 5 times x plus 1. Okay, to make it easier, on every interval, we are going to pick one point or one value that will satisfy our interval. For example, for x is less than or equal to negative 1, we pick negative 2 or we choose negative 2 because negative 2 is less than negative 1. So one of the most common tip, do not use the boundary. Do not use the boundary. Then for the second interval, as I said earlier, 0. You use 0 as a perfect example or a perfect value for this interval because it's easier to compute when 0 is involved. And then on the last interval, x is greater than or equal to 5. Again, we are not going to use the interval, and for it to make it easier, you use whole numbers. For example, 6. Now, this is called a sign chart because what we are going to do is to determine or to indicate what will be the sign of each factor. For example, x minus 5. If we are going to substitute x by negative 2 because our value is negative 2, so negative 2 minus 5 is negative 7. But what is our concern is just the sign. So negative 2 minus 5 is negative 7, or in short, the value of the value of x in this factor is negative. In this interval, if we are going to substitute negative 2 into x, and then for 0 minus 5 is negative 5. So again, we are concerned with signs. So 0 minus 5 is negative. How about the last interval? If we are going to substitute x by 6, 6 minus 5 is equal to positive 1, meaning the sign is positive. So I just hope you were able to follow. Next, let us consider the next factor. Next factor that we have is x plus 1. So if we are going to substitute x by negative 2, that will become negative 2 plus 1. And what is negative 2 plus 1? It's negative 1. Therefore, the sign is negative. So I think now you realize the importance of learning the signed numbers. Next value is 0. 0 plus 1 is positive 1, so sign is positive. Next is 6. 6 plus 1 is 7, that is positive. Next thing we are going to do is to multiply the factors, because that is what we were doing earlier. So we can have x minus 5 times x plus 1. So we are going to multiply and determine the sign. And that's very simple because we already have the signs. What we're going to do is just to multiply. What is negative times negative? That is positive. Next column, negative times positive, that is negative. And positive times positive, that is equal to positive. So again, when you are multiplying signed numbers, if you are multiplying the same signs, the product is positive. If the signs are unlike, the product is negative. So after accomplishing the sign chart, let us go back to our quadratic inequality. X squared minus 4x minus 5 is less than or equal to 0. The quadratic inequality should be on this form. It should be that on the right side it's 0. So that it's very easy for us to analyze. So how are we going to analyze? You look at the inequality symbol, less than or equal to, and then you answer this question. When are two numbers, because we are factoring. So when we are factoring, we have two factors. When are two factors less than 0? Or to make it simpler, when are numbers less than 0? The answer is if they are negative. And when do numbers are negative, or when do products are negative? It will only happen if the two factors are having unlike signs. Or to make it simpler, because we are already doing the sign chart, since we have less than or equal to or less than, you look for negative sign on your product. And if you are going to go back the product of the two factors, there is only one column giving you a negative sign, and that is this column, meaning this interval is our solution set. Therefore, the solution set is x is greater than or equal to negative 1 but less than or equal to positive 5. So again, how did we come up with this solution? Just look at the inequality symbol being used. If it's less than or equal to or less than, you look for a negative product of your factors. But if it's greater than or equal to or just greater than, you look for factors or product of your factors which are positive, and that will be the solution. So in this case, because it's less than or equal to, we look for the negative. Therefore, the solution set is x is greater than or equal to negative 1 but less than or equal to positive 5. Okay. before we proceed to the second example, the sign chart or the sign diagram is always composed of like three columns. But there are cases wherein we are going to have two columns because the reason is the factors are identical or the critical values are equal. So meaning if we are going to input that on the number line or we are going to plot that on the number line, it will only create two intervals. So that will be shown on the second and third example. Second example, x squared plus 12x plus 36 is less than 0. So this time our inequality symbol is less than. So we are going to transform that into standard form so that we can factor. And then when we do factoring, again we draw two parentheses. But there are times the polynomials are not factorable, so you use quadratic formula in finding the critical values. So x squared, factors of x squared are x and x. For 36, because this is positive, we look for factors in which if we are going to add the two factors, it will resolve to 12. And if you always do factoring, it's automatic. It's 6 and 6. Because 6 times 6 is 36, 6 plus 6 is equal to 12. So these are the factors. X plus 6 times x plus 6 is equal to 0. Applying ZPP, we can have x plus 6 equals 0 or x equals negative 6, x equals negative 6. So if you observe, the critical values that we got are equal. So negative 6. So if I'm going to plot it on the number line, this will be the result. So we have the number line. And then observe that what I'm using is a dashed line because the inequality that is involved earlier is just less than, no or equal to. So it's just less than, so you use dash, meaning when we have negative 6 is not part of the interval. It is not part of the interval. So if we are going to create the intervals that we have, first interval we have x is greater than negative 6. Going to the right, so all these values should be greater than negative 6. 6 is not included, so meaning we can have negative 5.9, 0 until positive infinity. On the other interval, its x is less than negative 6. So meaning, negative 6 is not included. So we can have negative 6.1, negative 7, negative 8, up to negative infinity. Now, since we only have two intervals, it doesn't mean you are wrong. It is because what happens or what the polynomial given, it's a special case. That's why we only have two intervals. So the same method, we are going to use a sign chart. So we have x is greater than or equal to negative 6, and then the other interval, we have x is less than or equal to negative 6. And then we are going to write the factors. The identical factors, x plus 6 times x plus 6. And then we are going to choose a test point. So for example, on this interval, I'm going to choose negative 7. On this interval, I'm going to use 0. Again, this is one of the easier way. If 0 is part of the interval, then use it. And then we are going to substitute. Negative 7 plus 6 is negative 1. That's why the sign is negative. On the other interval, 0 plus 6 is positive 6. So positive. And then, if you have that common sense, we just copied what we answered on the first row or on the second row because they are just identical. So we have negative and positive. So that's copying. Next, we consider their product, the product of the two factors. X plus 6 times x plus 6. Again, what we are going to do is to multiply the signs. Negative times negative, same sign, so that is positive. Positive times positive, same sign, so that is positive. Now, after doing the sign chart, we go back to the original inequality. X squared plus 12x plus 36 is less than 0. Again, it's less than, meaning we are going to look for a negative sign on the product. But unluckily, if you look at the signs on the product, they are both positive, meaning no intervals will satisfy this inequality. So if that is the case, then we can have this conclusion. Therefore, the solution set is an empty set, meaning the solution is not located on the real number line, no matter how you are going to extend. So if you can encounter the same problem, then you write or you use this symbol. This is a symbol signifying an empty set or a null set. Okay. Lastly, we have the third example. 8x plus x squared is greater than or equal to negative 16. So first step, again, standard form of a quadratic equation. So since we are having a greater than or equal to, then we are going to transpose negative 16. Then a little of rearranging, we can have x squared plus 8x plus 16 is equal to 0. So from negative 16 to positive 16. Next, we are going to factor 16. So factors of x squared, we have x and x. Then for 16, what are the factors of 16 such that when you add the two factor, answer is 8? That's very simple. It's positive 4 and positive 4. Because 4 times 4 is 16, 4 plus 4 is positive 8. And then you might be asking, Sir, why are your examples are very easy to factor, and then when it comes to the activity sheets, it's hard? The answer is very simple. You are brighter than me. That's why you are dealing harder problems. Yeah. After that, we apply ZBP. We have x plus 4 equals 0, x plus 4 equals 0. So we can have x equals negative 4, x is equal to negative 4. So this same situation strikes again. The critical values that we have are identical. So it is expected that on the number line, we can only have two intervals. And it is shown on this slide. We have a number line. And notice, this time I'm using a bold line, not a dashed line, because the inequality that we have earlier is greater than or equal to. And then the boundary is negative 4. So let's have the intervals. X is greater than or equal to negative 4, meaning negative 4 is included on this interval. And then on the other interval, x is less than or equal, x is less than or equal to negative 4. It should have or equal to. Less than or equal to negative 4. Again, negative 4 is part of this interval. So this negative 4 is not loyal. It is part of this interval. It is also part on the other interval. It is not loyal, but it is fair. Okay. So after that, we create the sign chart. And then let's have the interval. We have x is greater than or equal to negative 4. The other interval, we have x is less than or equal to negative 4. And then the factors that we have earlier, we have x plus 4. X plus 4. Let me change the pointer. X plus 4 and x plus 4. And then for the signs, again, we need to pick a test value. So for example, -5 on this interval. On the other interval, I'm going to choose 0. Again, 0 is my favorite. You know why? Because this is also the favorite score of my students. 0. Because they always got 100. That's why we have zeros. Okay, -5 plus 4 is equal to -1. So the sign is negative. On the second column, 0 plus 4, we have positive 4. So the sign is positive. And then using your common sense again, we are just going to copy. So in this video, you are just allowed to copy. And then after that, we consider their products, x plus 4 and x plus 4. So negative times negative, since we are having same signs, product is positive. Positive times positive, again same sign, so product is positive. Now after accomplishing the sign chart, you go to the original inequality that we have earlier. X squared plus 8x plus 16 is greater than or equal to 0. So the inequality that we have is greater than or equal to 0. Again, when are the products positive? If the factors are positive, or you don't need that one. Just look at the signs. Since this is greater than or equal to 0, it should be positive. And this time, all you can do is to sing, "Nasa iyo na ang lahat." But I don't know how to sing. So what we are looking is a positive sign. And if we are going to look at on this part, they are both positive. Meaning, this interval is a solution. The other interval is a solution. But in every interval, since -4 is included, meaning, nasa iyo na ang lahat. All the numbers on the number line are included of the interval. Walay makatakas. Therefore, the solution set is the set of all real numbers. Meaning, all the numbers on this number line are real numbers. Meaning, the solution are all numbers that can be seen on this number line. So again, if this video helped you, then thank me. Just kidding. Thank you for watching, and I hope that someday all of us will love mathematics, because that is the only solution to make mathematics easy. Okay, thank you, and see you in my following tutorial videos. Bye-bye.